So my name is Ian Cooper. I'm iCooper on Twitter. And I want to talk to you today about one of the dangers that commonly happens when people try to embrace microservices as a strategy, and that's that they end up with a distributed monolith instead. How many of you have a microservices strategy, regardless of whether or not you think it's successful? Okay. How many of you think you've actually got some kind of distributed monolith rather than a microservices environment? Okay, maybe more of you by the end. I was having a chat with somebody kind of on the way earlier this morning, and he was saying, is distribution in monoliths always bad? And the answer to that is no. What we're talking about when we use the phrase distributed monolith a lot is a particular breakdown where your microservices are very highly coupled to each other, which results in essentially you not benefiting from microservice architectures. Per se, it's not wrong to use distribution in a monolith. And that is because if you think about it nowadays, even a minimal application would probably be something running in some JavaScript, etc., running basically in a browser or something running in a WPF or Windows format, something running in an app server of some sort, and a database of some sort. So you've already got at least 3 pieces there, right? And that means you're distributed. So all applications are a little bit distributed, and you might in your monolith decide that you've got some long-running work that you want to take away from the web server, put onto a queue, and process with a worker process. For those that don't know, you'd quite commonly do 202 accepted rather than 200 with a link. The link says, where can you go to find progress, right, in the header. And that could be WebSockets, actually I subscribe to the WebSocket endpoint, or it could just be a poll. And you poll that and basically you get your results eventually at that endpoint. It could be the resource you're looking for that will be created, or it could be a genuine progress endpoint that tells you how far you're getting. And in the meantime, you put your work on a queue, and a worker processes that in the background, right? And that's all fine. That's using distribution to scale, because you can scale parts of your app independently, and it's using distribution to provide decoupled invocation, where essentially you offload work such that it can be processed asynchronously. That's not what we're really talking about when we talk about problems of distribution. What we're talking about is inappropriate coupling, and we'll come into that. Okay. Who am I? I'm not particularly interesting. This means I'm old. The point I would draw attention to is the one on the bottom. People who stand here aren't smarter than you. I am no smarter than anybody in this room, right? I'm here as a matter of privilege and luck. And mainly because when I first started getting into .NET, I was a C++ dev back in 2001 or so. I started getting into .NET, but there were no speakers. So we'd organise user group meetups and we'd say, whose turn is it next week? And we'd literally take it in turn to present on some aspect of the framework. And that got me over the hurdle of getting used to speaking in front of people. And that's really all that this is. It's an exercise in confidence to go to do it. And the only way really to get it is just to feel the fear and do it anyway. So please do speak at user groups, things like that. And you get to travel the world and stuff, so it's cool. I work on an open source project called Brighter. We do 2 things for you. One is we help you write essentially CQRS style apps, where effectively we give you commands, Brighter and Darker. One, Brighter handles commands, Darker handles queries, and essentially let you do separation between your controller, your SPNet controller, and a handler that actually basically runs the domain-based code. Runs a pipeline, you can insert stuff in between like poly. We also let you do that not just internally to application, but basically across the wire, using basically a message-oriented middle framework like RabbitMQ or basically SQS. You can think it's a bit like Mediator, but with basically the added advantage with distribution like N-Service Bus does. We are a very welcoming project. We have lots of help wanted issues. If you ever wanted to join us as a project, please do. You can join, and the first thing you can do is just fix our documentation. That's always really welcome, and people will love you as you learn. And then there's lots of little tiny issues with flag as help wanted, which usually we think are suitable places for a newbie to get started. We're going to talk about, we are going to talk about why you might want to go from monolith to microservices. And you may well say, Ian, I know that. I've been told that 1,000 times. I just want to basically go over it because there are some key points which I think get missed. And I see a lot of bad microservice implementations just based on a misunderstanding of what microservices are. Talk about what typically happens, why you end up in a distributed monolith. We'll talk about containers and service meshes. What are they? Why people use them? Do they really save you from the pain you've got yourself into? And then we'll look at basically event-based solutions. And when we look at event-based solutions, we will cover a couple of topics, reference data, event carrier state transfer, that most people don't really have an awareness of, that are pretty vital to you if you want to succeed at event-driven architectures. And if we're lucky and we have some time before Q&A, I might manage to do something about service consumer patterns, but we'll see how we are for time, given we're shorter. All right? Okay. I use examples of hotel software. If any of you work in hotel software, I deeply apologise, I know nothing about hotel software. The reason I do that is just because it prevents you from imagining that I'm talking about anywhere I've actually ever worked. And it also basically means that I don't get distracted by detail. So I just took a very high level of distraction of the idea. Okay, so this journey from monolith to microservices, why do we make it? So here's the problem. If I have a team working on my software, and that team is more than, Amazon would say, two large American pizzas. Commonly, people in the UK quite often say a team is, 5 plus or minus 2. If I have a large team, then it becomes a problem to manage all the people in that team. So normally what happens is once we get to a certain size as an organisation, we break everybody up into smaller teams. Right? Teams of about 5, 6 people. Is that roughly familiar to your experience, that kind of size? And the problem is that if I now have 3 or 4 teams working on my software, they have a tendency to get in each other's way. So typically this manifests itself in what we sometimes call the release train. So you come to release your software and you say, right, I want to do a release, basically you get my software out the door. And somebody else says, oh, yeah, hang on a minute, in order to get your software out the door, you've got a dependency on some work that other teams are doing. So that needs to come out at the same time. Great, now 2 of you are going out. Let me say, well, if 2 of us are going out, basically there's additional changes that we made on this side, just changes they made. Okay, we're going to have to check all of those things work together in harmony. So we're going to basically have to do a little bit of regression testing. And the other teams say, oh, well, for regression testing, I've got some changes I'd like to get in, right, etc. And then you've got all 3 or 4 teams with a list of changes they want in your next release. The problem then becomes, typically what happens is you go into testing and somebody's changes don't work right. Either because essentially when you've merged everything together it doesn't work, or because essentially you just got through their process and it was wrong. So they have to go back into the loop and try and fix it, or you have to decide to feature flag it out, or you have to decide to drop it from the release. And generally once they've done that you have to retest it. And usually my experience is this process takes something like about 2 weeks. And this means that your release schedule becomes essentially one that is hampered by the number of teams trying to basically work together. You'll end up essentially releasing, because it's a 2-week process, you'll say, we're not going to do that 2-week process every time, so we'll wait, 3 or 4 iterations and we'll start releasing every couple of months when it takes us 2 weeks. And your cadence then turns to 6 releases a year, maybe 12 releases a year at best. But being competitive nowadays tends to mean we don't want that inventory waste. We don't want features that could be earning us revenue and helping us compete against people in our market sitting idle for 2 months. Really, you can be competitive when you finish that particular feature and that story is complete, I want to release it. And that is the notion of continuous delivery. And it is impossible to achieve continuous deliveries easily with a team of, say, 30 people all working on one piece of software. So we want to break it up. Oh, I've got 2 credit card payments there. So that's that. I've given this presentation loads of times, and I've never noticed that. Okay, so we break up the teams and we say, okay, you are going to be responsible for this part of our application. You are going to be responsible for this part, you're going to be responsible for this part. And in order to make it possible for you to basically not get trapped in a release train, each of you will be able to deploy completely autonomously with the other teams involved. Right? When you press the button, you go. When your feature set is done. And that means you must not be coupled to anything anybody else needs to release. The most common case is the database. We must not share the database. Now, it doesn't mean we can't all live on the same database instance. What we mean by that is we can't share tables in the database. Right? If you cannot have the two teams reading and writing to the same table, that will not give you microservices. Because now I am bound by changes they may choose to make to the schema. So each one of these teams has to be entirely independent. And generally, our preferred model is that each one of these teams has its own product manager and its own backlog and is able to prioritize work across its individual area of the application. So we have teams working on how we do channel management, on booking, and teams working on how we do payments that are the accounts. And they each have their own backlog they're working through. And we will notice occasionally we have to do a program of work across everybody, and then we will slow down. We will feel much more waterfall. But if we generally want to be agile, we want to break up our application into a series of microservices that give us that agility of teams working independently of a backlog, able to release as soon as the feature is complete. And that is what microservices are about. And that's one of the reasons we say to people, if you work in a team of 3 or 4 people, you don't need microservices. That doesn't mean you won't benefit from distribution, right? You could benefit from basically using task queues, etc., from being able to scale parts of your application independently of each other. But microservices themselves as a strategy are oriented around creating teams with their own backlogs for their own basic pieces of work in the application, right? Occasionally when I say that, people hate me because their manager's here and the manager's going, you see, we don't need microservices. So what we're saying is, as a strategy, it means something very specific. And the trouble is, like all terms in software, it tends to bleed a little bit. And everyone just thinks it means slicing up your software in some ill-defined way. And it doesn't. It's actually quite defined about how you should do that. So, where is that slide? Okay. Here you can imagine, you see we've got basically various parts of our application all sliced up, and each one of the parts of our application has its own API and its own database, and is maintained by its own team. And here you can see the idea is we are communicating between the parts of the application by a bus. I will come back to why we might choose that strategy opposed to others later. But the key thing to understand here is when we sliced up our application like this, we need some stability. So the client of direct bookings wants that direct bookings API not to change too much, right? We've written some code in Angular and it's now hard to change. So we'd really like it didn't change the API too much. So we want an API for bookings that is relatively stable. But we also want to have stability between our microservices. Having sliced a part out, I want to make sure that I don't have to keep reorientating that. It becomes difficult if direct bookings essentially has to talk to 12 different microservices that keep changing every week, right? That may imply some upstream work. Now we'll talk about how you can alleviate those concerns a little bit, but generally what we want to do is have some kind of stability. It also helps teams, right? I don't want to be in a new team every 4 weeks. I'd like to be able to create some knowledge around how I do something, get a little bit of consistency, build up some expertise in the given domain area like bookings or payments, and be able to essentially improve the product. So that implies that what we need are stable boundaries. I need to find some boundaries when I slice up the application that I think are going to be relatively stable. So how do I do that? So a typical use case in the days of SOA, which actually if you read, say, Fowler and Lewis and microservices is still their recommendation, was to use something called business capabilities. And the idea is that essentially a capability models something that a business does for a customer, or something that supports our ability to do something for that customer. And capabilities are quite often defined as a noun, maybe a verb plus noun, depends on your technique, right? So something like effectively underwrite policy, or check claims, or rate hotel would be essentially capabilities, things that we can do. A typical one that I often call out, for example, is lead generation. So your marketing department will do something called lead generation. Lead generation is essentially how they create the sales funnel, where they drive effectively potential sales prospects, the salespeople, to sell stuff. If you go and look at any marketing department out there, you will tend to find it's doing lead generation. Now, it may have different ways of doing lead generation, right? And they may have different strategies they use that they think are going to be successful in their context for actually basically generating those leads, but there's always going to be a thing called lead generation. So lead generation is a relatively stable boundary for us. We could create a capability if we are creating a software platform around, say, a business which said lead generation. And that would be stable over time. We would be able to basically orient a team around effectively that and say, you have the product backlog, go and talk to marketing, figure out how they do lead generation, make it better for them. So those are the kind of things we tend to look for when we're breaking up a microservice, business capabilities. Typically, one of the ways that if you go and talk to enterprise software people about how we find capabilities is typically value chain mapping, which I won't have time to go into, or event storming are typically good ways of finding capabilities. So value chain mapping just literally says, how do I basically figure out what a process that my business runs to deliver service to a customer end-to-end looks like? And if you get enough value chain maps together and cross them over, you can actually find the stable processes in the middle. Event storming is kind of similar. It's a model which basically says, given an input to the system, what events do I generate, what events do they generate in turn, etc. And kind of the gaps, the things that are sources of event generation are quite often capabilities. Okay. So when we talk about capabilities, there are a number of levels. So we're only going to show 3 levels here. There are typically also potentially 4 or 5 down below, right? So level 3 is the one we care about most all to discuss right now, business capabilities. And so that is where we will find microservices. So what are they? Well, let's go back up a bit. A capability group is essentially some part of the organization, typically that has some kind of ownership for part of what the business does. Okay, marketing, underwriting, sales, etc. Right. And they have a set of things they need in order to basically provide value to the customer or support basically us providing value to the customer. Up above them, we get essentially the very high level notion of operational and environmental capabilities, basically the foundational parts of our business. All right. So business capabilities are things that these higher level groups do. So claims will basically do some kind of claims assessment, underwriting will do some kind of risk rating, right? Housekeeping may well run the kitchen, and the concierge tends to run the check-in. So you can see this kind of model here. So if I look at my hotel software, I know nothing about hotels. A level 1 might look a bit like this, right? We've got basically all the things you might expect to support our business: human resources, legal and compliance, accounting, sales and marketing, etc. We've got all the things that our consumers will tend to interact with: rooms, food and beverages, etc. Purchasing and receiving is probably back end, sales engineering, right? So those are the ones that tend to be the ones the consumers will see most of, perhaps security. So you can see we've got operational and environmental aspects basically to our capabilities. Now if I take one of those, like rooms, it's likely that I've got a series of pieces that deal with how I manage rooms. So I've probably got some kind of reservation system that customers book rooms. Okay. Some kind of front office which deals with when you actually turn up on site looking to get access to your room. A concierge, basically helping you look up, figure out what you want while during your stay. Entertainment, you basically might want to use our video system on our television or whatever effectively. and housekeeping, keeping your room clean, right, as the capability groups. And I could break those down a bit further into what are probably actual business capabilities. So I could look, for example, at the front office and say, well, probably we have a check-in, guest information, and check-out service, right? We have some kind of process for checking you into the hotel, some process for checking you out of the hotel, and some kind of process if I want to provide you with additional information during your stay. I might have some reservations about direct bookings, I might be able to book for events quite separately. I probably do channel management. Channel management is when I talk things at sites like booking.com or Expedia and basically tell them what rooms are available and book through that process rather than booking directly. Right. Anyone taking pictures, by the way, please don't build your foundations of your new startup on my 5-minute analysis of capabilities. But those processes there, the level 3 ones, are essentially where you should target microservices. And notice we're not talking about specific entities, right? Entity services are generally an anti-pattern. If you have a service that basically provides CRUD for a given entity, that is not a microservice. It will be part of a microservice, but it's not a microservice. Okay? Because these are the right levels of abstraction that should remain stable over time for you to orient the given team around and provide basically service to other parts of your business. Bounded context. So some of you at this point may be saying, Ian, I thought microservices were around bounded context. Bounded contexts are a very useful idea and they come from domain-driven design. And what bounded contexts say is that your domain model is a model in which effectively a series of terms have meaning, whose meaning is limited to that particular model rather than generically to the whole application. So the classic example would be in insurance. Lots of people in insurance talk about a policy. But what a policy records and what it's used for is quite different for the claims team and the underwriting team. So DDD says, okay, they are actually two different bounded contexts because the word policy means something different. Generally, you will tend to find that a business capability is a bounded context, and you don't want to split bounded contexts across business capabilities, right? You might also find that your business capability has a couple of bounded contexts, and that's quite possible. So there isn't really a one-to-one alignment. And one of the things about DDD is although it basically expresses the idea that there are bounded contexts, it doesn't really tell you how to find them, although it does mention essentially that they're quite often aligned to business capabilities. There's a bit of a chicken and egg scenario, unless you know what business capabilities are, it can be hard to figure those out. Right? So bounded contexts are very useful, but the question is how do you find them? And the answer quite often is business capabilities. Event storming, etc., it will find you bounded context, but really it's kind of a variation on value chain mapping. Okay. It's quite a black art. I'm going to try and do a talk next year to talk more in depth about how you do capability mapping. So I would be at various events around next year trying to give more detail on how you do this because it's not very well documented out there. Okay. But imagine I have done that. I have basically decided on these stable boundaries and I've got roughly the right size. Right? I often talk about Goldilocks services, not too big, not too small, just right. And I want to break up. What typically do I do? Well, our typical model in the past has been to say, okay, what I need to do first of all is take the code that represents that particular capability out of the monolith and put it into a new piece of software, new service, right? Put it into a new repo in GitHub. When I do that, I might do a tiny bit of cleanup, right? I might say, you know what, we always want to put proper layer boundaries in, and you know what, the tests are awful, let's get a few new tests in there. But generally, don't try and re-engineer and don't try and rewrite from scratch. Why? Well, generally speaking, if you try and rewrite from scratch, you'll find all the reasons why the code was so bad in the first place. Because all those edge cases and stuff that you don't really understand creep in and you have to try and fix them. You're better off putting yourself in a position where you can refactor to improve the structure of the code with those kind of rules already baked into the software that you're building. But the first thing to do is just create a copy. Just create a copy of that code. The next thing to do is essentially, slightly sliced off. Your microservice probably communicates by the outside world via an API of some sort. I don't have a particular restriction on how it's going to be, HTTP, gRPC, events, but it's got some kind of communication with the outside world, right? It's now a distributed system, so it has to talk to everything. And so over time, what you want to do is direct all the traffic that used to come to your monolith for that particular piece of work to go to your new service. So if you essentially now have the underwriting area, if you're doing basically risk assessment in underwriting for a given new risk that's come in, then you want to make sure that everything that used to come here for risk assessment goes here. Now, if you've got an API up here, that's pretty straightforward because essentially you just create the API over here and you start shunting the work over to here. If you haven't got an API over here, sometimes you have to go backwards and put an API in here and then the same API here so you can shunt work across to here. Sometimes you just say, I'm going to basically intercept at some point and make the calls across to the API over here. Right? And that's quite typically the format you quite often say, I'm going to go over here, I'm going to basically just shunt whatever calls I used to have now to be calls to the API over here on the service. And that's called asset capture. Eventually, there's nothing calling the code that basically deals with that given capability within inside your original monolith. So all of my work around underwriting a given risk has now moved into my new service and nothing calls here. So I've captured that asset and all the traffic for that asset goes through here. Okay? And then I can essentially say, well, that means there ought to be no writers to the data in here that service used to own. And I can essentially move those tables across over here to their own database, and this now becomes the single writer of that information. There should also be no readers because the readers should be going through the API. So now I have basically ownership of that table and nobody over here has rights to it. And quite often, typically, you just essentially turn off all permissions to the table over here, see if anything breaks. If it does, you've still got something else to fix. If you haven't, then essentially everything's now talking to microservice. All right, and you simply repeat that process. Rinse, lather, and repeat, right? You keep going until essentially your monolith's been broken out. If you're lucky, you get all the way. A lot of the time, you get 80% of the way, and then there's not a lot of value in the bits that are left, and they get left in the monolith, right? And Twitter tells the story of how for ages it had this kind of Ruby on Rails tiny bit of its monolith still left that did some rendering for it, that no one could ever be bothered to actually finally decommission into a microservice. If that happens to you, that's just part of the course, right? Lots of microservices journeys are journeys. They don't ever reach a destination. Okay. But there's a little problem that tends to happen when you do this. And it may be inevitable with the technique, right? So it may not be, so if you are in this trap, don't think, oh no, I've got it wrong. It's just, you then tend to encounter this particular problem. So when I had my hotel software written in my monolith, it was fairly easy when a customer wanted to make a booking on account for me to deal with that situation. So what used to happen was the customer would call my API basically from my Spa client or my phone app, and it would go to the direct bookings basically API and say, I'd like to make a booking please for this customer on his account. So I'd go to the database and I'd say, via my ORM, let's get some account data back. That's probably got my credit card details on it, great. I'll pass that to my payment system. Yeah, the customer's paid for it, great. I can tell housekeeping that I need to book a room on this given date, and they should get one ready for me like a day beforehand. I'll tell the channel manager that deprecate the number of rooms available on this date on booking.com and Expedia so we don't get overbooking. Right. Very straightforward. And what typically would happen in my code is I've got some code, like this ridiculous pseudocode saying, oh, basically, I've got a booking, I'm going to go and get save the booking, going to go to the accounts, get the customer's card details, take the payment if they paid, etc. That kind of thing. Right. When I come to basically do my transition, I'm typically hitting the problem of, okay, I'm about to, in my microservices world, once I've broken accounts out, how do I get hold of the account details? How do I make the payment? Because I've probably got a situation that looks a bit like this, okay? Where effectively in my direct booking system, essentially it's got credit card payments and accounts and housekeeping and channel manager. So how do I do that? And typically, our answer is simply to replace this given call here, get card details to take payments, with some kind of a call, request-driven call basically to an API. So by request-driven, I mean HTTP or gRPC or something similar, where effectively what I do is I call your API and I expect a response, request response basically over a synchronous blocking connection. And there's a slight problem with that. And the first problem is called temporal coupling. Now if you imagine my model is like that, what happens if the accounts microservice is not available? Customers can't book. Simply put, whenever I try basically from my direct booking system to then get the customer's credit card details and get a fail, because that call is going to return with something like a 503 service unavailable, or whatever it is for the protocol given protocol that I'm using. And so I've lost that booking. Customer's going to go to different hotel this weekend, you know, we're screwed. Once upon a time, there was a DDD North, and the DDD North was located, I can't remember what it was, some kind of conference centre, and the conference centre had a hotel attached to it. And for some reason, I'll never understand, this massive hotel attached to a conference centre only took bookings over the telephone. It wasn't that long ago, and generally there wasn't anybody there. So you'd phone up, and there was no way to actually book. And only two of us, Dave Evans and I don't really know Dave Evans, managed to book into the hotel that was literally 50 feet from where the conference was taking, and everyone else was scattered across basically the town in various different locations. It's kind of like The Shining. There were two of us in this massive hotel that was completely empty. The security guard turned up, basically there was no hotel staff because there were so few of us, gave us the key and said, you let yourself in and out and we'll pick up the key from you when you finished your stay, sort of thing, etc. And it was bizarre. Also, what was even more bizarre, in a hotel of 600 people, 600 rooms, they gave us 2 rooms next to each other. I never understood that. But anyway, yeah. So but basically, you can think of request from just a bit like phone calls, right? Essentially, if I pick up the phone and I call you, and there's nobody there, it's really annoying. Who phones people nowadays? Right, about one person. My mum phones me, but that's really about it. Who uses basically WhatsApp, text, Slack, some other messaging service? Some of you have no friends, obviously. But generally we do that because it's an asynchronous process. It doesn't matter if the person you are sending the message to currently has the phone in their hand, right, and is waiting for a receipt of that. If they've gone to the kitchen to make themselves a coffee and they come back, they can get your message and look at the phone. And that's basically a really useful property for communications, because otherwise it's very, very frustrating when I'm trying to get hold of you and I can't get you. And the problem with request-driven architectures is they have exactly that problem. They're like telephones. If you're not there, it's a problem, right? Ian Robinson sometimes calls them emergency services, basically. If you call them and they're there, it's fine. If they're not, you're shit out of luck, right? It's a problem. Another problem is behavioral coupling, right? What happens if the team that currently build housekeeping say, housekeeping has become too complicated as a single microservice. We really are struggling basically with the requirements we're getting. Housekeeping has become the best-selling part of our software, and we need basically more than the 7 people currently on it. We're going to have to put like 15 people on it. We need to break up into teams, okay? And you start going down from level 3 to level 4, right? In your capability breakdown, you start looking at, you generally think called activities. And you say we start creating microservices around those. Now, you don't want this to happen too much because it's essentially quite an expensive process. But what happens if I do that? Well, the problem is everyone else upstream, or downstream technically, is going to have to change their code in order to basically call my new services, right? I need to be aware that essentially from direct bookings, I'm going to have to talk to whatever service it is basically that manages basically bookings, or somebody in the concierge has to separate now cleaning and laundry calls to different APIs that may live in different IP addresses, different DNSs, etc. across the system. So releasing that becomes a pain, becomes quite risky, etc. and difficult. Right? And that's called behavioral coupling. All right, so there's the 2 problems with request-driven architecture. So For the first problem, temporal coupling, what's tended to happen over time is people say, well, we can solve this problem. Don't worry about it. We'll simply make sure that there's always an account service. And so what they do essentially is they say, well, the first thing we could do, right, is we could say, let's have multiple instances of our account service running. And because essentially I want to make sure that you just call whichever one's available, I'll put it behind a proxy, like Nginx or HA proxy. And that will declare an upstream group and it'll have some health checks. And it will round robin requests to a healthy instance. And I can have 10 instances instead, and that will make sure there's always an account service available when you're there, right? So I can work around this problem in theory then, effectively, of lack of availability, by making sure that I provide enough instances that the chance of me being unavailable are small enough. And while I'm there, what I tend to say basically is, oh, well, you know, as well as load balancing and health checks, I could do things like circuit breaking. So I could say, oh, well, you know, effectively cut off that particular instance that's performing badly. That then leads us to say, well, interestingly enough, if I've got all these proxies, I could use proxies to do monitoring because all the traffic has to flow through my proxies. All my configuration, like where to call stuff, I could basically do that through my proxies. Discovery through my proxies, etc. And then you end up with something like console, and then later on you end up in something like Istio, and you've got a control plane and a data plane that's a service mesh. And all a service mesh is, when you see the word service mesh being thrown around, is a proxy that's trying to make an app more available. Simply that's all it is. And if you're currently using any kind of proxy over, you know, a whole set of instances of your web application, you're pretty much doing the same thing a service mesh is going to do for you, right? They've just got fancy branding and vendors crawling all over, etc. But so don't panic if you see that word thrown around. And that's certainly a solution. But when we talked about microservices, right, the idea was supposed to be that there was kind of like, it was derived from gRSOA. And this idea that we don't really want to have these big centralized, centrally controlled things that effectively are governing how we do our microservice efforts. We want all the smarts to be in the microservices themselves. We don't want stuff to start bleeding into the logic in between. All the routings and business logic floats up into gateways, and the whole thing we start to lose control over it. So the question is there an alternative to going down this route, right? Because if I go down the route of request-driven architectures, and I go down that route of replacing my simple in-process call to another part of the application with a HTTP call, I'm going to end up basically with a service mesh and a lot of complexity, and everyone's going to go, wow, microservices, these are really painful. Why did we ever start this idea? So is there an alternative? All right. Events. So, rather than trying to make this approach of basically using a direct call, what I could do effectively is just use events. So in this model, I've introduced a broker. So that's basically some piece of message-oriented middleware. It may be SNS and SQS on AWS, whatever the equivalent in Azure is. It might be something running effectively in a data center like RabbitMQ or even Kafka. It doesn't really matter, but there's some piece of middleware I'm using essentially which allows me to basically asynchronously send messages between two applications. And what happens is something like direct booking raises a message and says, I have had a direct booking. And it simply publishes it out to the broker. And it doesn't know anything about anybody else in the universe. It just says, I've had a direct booking. And then what happens is other people can subscribe to that. And usually it's quite often thought as a topic, right? Or a channel is more technically correct. Others can subscribe to that and say, when that's published, I'm interested, give me a copy. And that means, for example, housekeeping can say, I want to know there's a booking, I'll subscribe to that. Now notice that direct booking doesn't know anything about housekeeping. All they're doing is communicating via a logical address with basically the channel. And so it sends a message, housekeeping decides to pick it up, and it's all good. The other advantage is that essentially, if channel manager is down, when I publish my notification that I got a direct booking, usually what we do from the broker to the actual application is use a queue. And the queue simply saves that message when I'm not there. Same way as WhatsApp will save messages for me basically when I'm not there. And it says, great, there's notification for direct booking that you need to tell everybody basically we've got less rooms available. We can simply keep stacking them up until that service becomes back online and can process the messages. Now, you do have a couple of tiny caveats. Obviously, essentially, when Channel Manager comes up and starts processing the messages, there is a degree of latency involved in that. It's possible that because we haven't told Booking.com that essentially, while room availability is down, someone is now going to book a room when effectively we really didn't have availability. People get very concerned about this, and there's a couple of things to bear in mind. The first is, if I essentially had a website and I was doing this sort of request-driven architecture, I still have that risk. Because the risk is when the direct booking, when someone does the get to say basically make a booking, somebody else effectively has done, meantime, a post that hadn't been processed at that point, right? And the post is working its way through, the booking is working its way through at the other end, and the two haven't actually synced up at any point. It's just more exacerbated here. The second is that most businesses that are been around for a while, pre-basically information technology, have ways of resolving this problem because it always used to happen, right? So generally you'll find that hotels overbook anyway, and they have a strategy for what happens if everyone actually turns up on the day, which is to push you to an overflow hotel instead, right? That's happened to me recently. I got upgraded from a Holiday Inn Express to an actual Holiday Inn. Housekeeping, so not my current partner, but my ex-wife and I used to once a year, we'd go to fancy hotels. We went to the Dorchester in London for one night living like the rich do. And we turned up, and it's a really expensive room, and they had a problem that housekeeping had not yet been notified effectively and cleaned the room, right? There's some rock star partied like crazy in there beforehand, who knows? And I'm like, this is a really expensive room, and I can't get into my room, and they were looking at me that look of it maybe some time before we've cleaned the stains off. We don't really know what they are. And they simply said to you, don't worry, sir, please go to the bar and order whatever you want on the house. Several very expensive Dorchester cocktails later, I didn't care that my room wasn't available. So there are usually well-known strategies for dealing with a problem of eventual consistency in business, because it's traditionally what happened. And one way to people think about this model is, if anyone who's old enough to remember when we used to have trays on our desks that basically you had, stuff coming in and stuff going out. Most businesses do have models of historically for dealing with this stuff. All right. But events are effectively, for those of you that never remember that, a bit like WhatsApp, and requests are a bit like your mum phoning you. Right? So, there are a couple of things people have to kind of grasp that they don't usually know about when essentially they are doing this. Move reasonably quickly. The first is that if I've made a booking on account, booking comes in, credit card payment says I only take a payment for it, I'm supposed to look up the account holder's information. I've got a problem now, because I'm now about to do a request, right? This is the classic problem of joins. Now I've sliced up my microservice into a number of independent databases. What was previously easy because I could join data across tables has now become excruciatingly hard. And if I go back here to calling the API of the account system, I've just reintroduced the problem of basically being independent of temporal coupling, request-driven architectures. So I don't want to do that. What do I do instead? Okay. So there are two general options. One is effectively make sure that when a credit card payment receives the message, it has everything it needs to process it. In other words, essentially, I make sure that I include the customer's credit card information when it's sent to the payment system. And the other is give the credit card system all the customer's account details ahead of time. Right. So all messaging systems essentially can support pipes and filters architectures. So the model really for making sure that credit card payments can have the right information when booking on an account will be direct booking raises a message, account listens to direct booking made, and it says great, or direct booking made on account, it listens to that message effectively and says great, I'll listen to that. I will add the required credit card information and I will then raise a direct booking message which credit card payments can listen to. And certainly that could be the same message that something at the front end is raising for non-on-account bookings. So guest account bookings may basically just have the credit card details attached anyway, right? That's a pipeline. That's called content enrichment, that little step, where essentially we are moving a message down through various microservices until it has what we need. If it gets complicated, that's where you end up with basically this notion of a saga you may have heard about. And the notion there is that I want to actually do some kind of basically orchestration around that process. So I tend to have some kind of something in the gateway that says booking is being made, call direct bookings, it will store the booking and tell me it's done that. So the tin cans are channels, and you can do a request responsive messaging. So I send the message saying reply on this channel, and then you send the reply on another channel. So API gateway effectively stores a current state of the state machine and says I'll wake it up when it comes back, and then I'll send it to accounts. Accounts will give me the account information, and then I'll send it to credit card payments. Right? And each one of those is an exchange, a request, and a reaction. Send a message to the service, get it to create some data, get it to raise a message in return. I then correlate back at the top service to the state machine, move it on to the next step. And I work through this series of steps. Effectively, it's made advantage I can do compensation. Tend to prefer orchestration until you know you need compensation. So orchestration, one we saw earlier, events just listening to given topics, but this can help you if it gets complex. Okay, the second option is to do a thing called reference data. So basically, this is what a service looks like, right? Essentially, you can have multiple processes in here, but effectively we have a boundary. It's an explicit boundary defined by an API. It's autonomous, in other words, you have our own database, we can be released independently, and we're sharing basically information by a schema, not type. In other words, we're using something like JSON or XML or Avro as a wire-based format, right? Please don't share type because like .NET assemblies, because essentially that won't work if effectively you have a heterogeneous environment, you've got some Java or Python devs in there. And when we look at this stuff that we're sharing, and a couple of things we know about it. The first is when it's stale, as soon as basically it leaves our boundary. Because once it leaves the boundaries on the wire somewhere, we could get more API calls in which will change the state of what we've got, right? It's immutable. There's no point in me changing that, or the event, or basically the response I get from basically a get-based call, because it won't write anything to the owner of the data. The owner of the data is direct bookings. It's the single writer and the only thing that can actually affect the actual data. And also it's probably versioned. So here you can see we can get a version for get if it gives us the last modified, we can ask it an if modified since and say get me ones that are later than that. And we can put just versions on a message, right? So single writer there. Data on the wire is immutable, stale, and version. The interesting thing about this kind of data, inside data and outside data, is it's very cacheable. So the way the web scales is to cache outside data, right? And so those of you that do, web-based stuff probably know that we tend to have things like a forward proxy, a reverse proxy, and a browser. All of them can cache data. So you can go locally to the nearest cache to you and access that data. Lowers the latency at the risk of it being stale. Right? Now, single write of the data, local copies. And what I can do essentially is exactly the same thing. It's called event carriage state transfer. And the idea is that essentially my credit card system is just going to basically keep a copy of account information. But rather than doing a get and caching it, it's going to listen for events raised by the account system. And the account system will tell me about lifecycle events, create, read, update, and delete on basically individual accounts. Customer changed their credit card, customer changed their address, customer changed their name. And I will then update my local copy. So essentially, I have a cache of that data. And that means when I receive a payment request, well, I'll just show you putting that up first of all. So I have a worker processor part as part of my microservice that's reading the information off a queue, updating my local copy of the accounts data. When I receive a request to take a payment on a given credit card for an account, I just go and look up the account's information locally. Right? And that means I am isolated against failure. If the account system is not available, I don't care. I have the data I need to process them. It's possible that a new account has come in before I've managed to process the worker data. I've essentially got a slight problem, but you can get around most of that. This is the idea called bulkheads, the idea that failure of another service doesn't impact you. So effectively my payment system can keep working even if accounts is down for most of the customers who are booking on accounts that already exist. Right? There's actually called event carriage state transfer. And that's essentially, those two processes are how you avoid that request call then creeping in microservices. Joining is the problem you don't want to do. Right. Okay. And in turn, I raise my own messages. Right. Okay. ECST is one mechanism to do this. Traditionally, we did things like expose atom feeds. Atom feeds are highly cacheable, so you could essentially call an API on the account system effectively to poll it basically to find if it had new records. Extract, transform, and load. Huge numbers of banks replicate this data out basically to various downstream systems, just using basically classic ETL processes. And if it's slow enough moving data, you can even FTP it across, right? And typically you get a problem around seeding, which tends to mean essentially you quite often have to use one of these processes apart from ECST, unless you're using something like Kafka, which effectively is a stream-based technology, which effectively gives you that list of changes for new databases that come into play. And that's where things like Kafka have a strong use case. All right. So our model becomes a bit like this. Cut and shunt, we mentioned before. Asset capture, get everything to come to our service instead. Right? But then what we want to do is force events out the monolith to consume our downstream service. If you don't currently have events in the monolith, an easy way of doing that is triggers on database tables or scraping audit trail tables, or things like Kafka will actually basically have a thing called a connector API that will actually scrape data out of databases for you and put it onto streams. And that gives you events that basically help drive your service in future instead. And then you might have a reference data store, which tells you basically about all the data you used to get out of here can now be stored in here, so your service doesn't have to call back into the monolith for that data. Right. Quick note on API composition, we're almost there. So, given I've got all these services, we do still have to do some join. So join across the database is the problem. So we've solved the problem by events, by ECST, or basically pipes and filters of how one microservice talks to another. But what happens if my client needs data from multiple microservices? Right. So the easy answer is client-side composition. I just call all the microservices that I need to talk to and collate all the data on the client. Pretty straightforward, right? And certainly if there's no business logic involved in that process of how we basically collate that data together, pretty easy. But it's going to not work very well for things like mobile, where essentially connectivity can be an issue. So a typical response to that is to do server-side composition. So a gateway, although API gateways are products that vendors make, a gateway technically originally meant basically a layer effectively that sits above my microservices and does some composition on the server-side for me, right? And something like GraphQL is really just acting as a gateway quite often to do composition over multiple microservices. Like Apollo, that's all you're really doing. So you can compose on the server, and the advantage of that tends to be that it reduces the latency because you tend to basically make one call and get back a bigger payload from the server side. Right? There is another model though, which can be very useful, which says I'm still basically making a lot of individual API calls once I hit the server side. And that could be a lot slower than the call I'm making with the monolith to talk to just basically join data from the database. So the other model is called a composite view model. And what that says is I basically create a service that listens to events and pre-calculates the view that you want to talk to. And that's very fast because you can basically create a database that's completely optimized around that REST call that you're making and says that's just going to be one row in that database that I'm going to pull back that's going to give you all the information you want in response to your call. And it doesn't work for real-time data. So for example, if what I wanted to know was what is the impact of it raining out, of the weather outside, it's raining right now, it's hard to pre-calculate that stuff. So you tend to have to make API calls. So if I've got recommendations algorithm for bars to visit from my current location, right, then it's going to want to care about real-time data like weather. I can pre-calculate a lot of the things based on whatever preferences you've given me, what beer you like to drink, whether you like moody dim lighting, whether you want the chance of a fight to be good or bad, right? You may have established that with me beforehand, and I can give you a certain amount of data, but I need to interpret that alongside some real-time data, like weather, to eliminate a certain number of those results. But otherwise, you can do a huge amount by pre-calculating that data. So that is a kind of like CQRS-like idea of saying, I want to build this view model that's a composite based upon the events that I've seen elsewhere and put a simple API over the top. All right, great. And the idea is just to become more loosely coupled, right? That we're moving away from this distributed monolith that's highly coupled as a model. Oh, I've got some animation. That's fancy. I don't know why it's going to credit card payments though. Okay. Yay. Okay. And that's my order history over there, right? Telling the customer about what I booked before, when I booked, and we can go and have a look at that. All right, I'm not sure we're any time for questions. No? All right, come on. I want to vacate this space for the next speaker. So just grab me. I'll try and wander out. I'll stand over there and I'll try and wander towards coffee in a bit. My DMs are open on Twitter. You can DM me.